All right, today we're going to talk about power functions. So what are they, how can you solve them, and then how can we actually apply them to other stuff? So what is a power function? A power function is a function of this form. So you have f of x or y equals k times x to some a. So a is some number that's not zero, because if it's zero, then it just disappears and you just have a constant. So your a value right here, this is some number bigger than zero. And then k is some constant, so that stays the same. It would be like 2, 3, 4, -1, -1/2. That also can't equal 0, otherwise your equation kind of just disappears. So what do they look like? Here are some power functions. I'll zoom out a little bit. So below are 4 different types of power functions. Actually all of your power functions are going to look kind of like one of these. So first one, we want to think about if a is less than 0. So if your a value is negative, what kind of function does it look like? I like to think of an example. So an example of this would be if y was k over x. So x to the -1, k over x. This is going to end up looking like that because that's our basic function. So if we look over here, that's like this purple one. You will want to memorize these because they're going to be on the quiz as like multiple choice questions. So like, what does this equation look like? Next, we want to figure out, well, what does it look like if a is between 0 and 1? So what that means is a is a fraction. So you could think of like a equaling a half is the easiest one for me. So you end up getting k times the square root of x. You know what that looks like. It's one of our 12 basic functions. It looks something like this. So that's going to look like the red one right here. And then we're looking at when a equals 1. So if a equals 1, you have kx to the 1, which is just kx, or a linear equation, which looks like that, which means it's going to be the blue one. And the last one, by default, has to be the orange. But if we talk about y, if we're greater than 1, the easiest for me to think of is x squared. Well, I know that looks like this. If we're looking at this chunk, we're looking like the orange one over there. And then you can think of, like, if something is negative, it would reflect down over the x-axis. But that's the basic way they look. Okay. So looking at this, each graph of this one goes through this point right here at 1, 2. So this is not a coincidence. We have to think about, why does this actually happen? And so if you can think about this, all of ours here, we had y equals some k x to the a. So if you plug in 1 for x, you get k times 1 to the a. No matter what a is, this is still just going to be k. So it's going through our k value. So from looking at this, we can figure out that k has to be 2 because they're all going through y equals 2. So more things with power functions. Power functions, like a subcategory, if a is positive, if a is greater than 0, they're called a direct variation. So examples would be like x squared, x cubed, anything like that. If you're negative, so less than 0, it's an inverse operation. So that'd be like 1 over x, 1 over x squared. We're going to talk about these in more detail. So direct variation. We have an example. If a equals pi times r squared, so this would be the area of a circle, this is a direct variation. So we could say a varies directly as r squared, a is directly proportional to r squared, or a is just proportional. So any of those words mean direct variation, and we're going to be talking about word problems in a bit, so you want to know that. If we're looking at this, the standard basic form would be y equals k times x, and then this x can be any variable. It doesn't have to be x. It could be like r squared, it could be x squared, it could be r cubed, s to the 4th, anything like that. This is like holding the place of your variable. And the question at the bottom is, what is a constant proportion, or what's the what's it called? Constant, a variation, constant. That is then going to be the pi, because pi doesn't change, that stays the same. So this is like the k in the equation. Inverse, same idea, except you have y equals k over x because you have a negative x value. Again, this can be any variable. We'll rewrite that. So it could be like 1 over x to the third, 1 over r squared, 1 over square root of r, anything. You're going to say with this that y varies inversely as x, or inversely to x, and then y is inversely proportional to x. You want to look for the word inversely when you're looking at word problems. The constant of variation in this one then is just k. So a couple examples. So we want to write the equation first that expresses this sentence. So it says z is directly proportional to the square root of b. So the first thing you want to think about is it directly proportional or inversely proportional? Well, it says right here, directly proportional. So we have the form y equals kx, and we want to figure out what's k and what's x. So it says, or what's y and what's x. If it doesn't say what the constant of variation is, just use k. So it says z is directly proportional to the square root of b. So y is going to equal z, and then our x is the square root of b. So it's not just b, it's the square root of b. So if you write this out, we get z equals k times the square root of b. The second part then gives us actual values. So z is 35 and b is 49. What's the constant of variation? So it's asking, like, what is k? And then we want to rewrite our equation from up above to include the k value. So if we plug this in, we have 35 equals k times the square root of 49. 35 equals k times 7, and k equals 5. So then if we rewrite the equation, we'll get z equals 5 times the square root of b. And that's that one. All right, for this one, pause and try on your own, and then we'll talk about it. Okay, so it says g is inversely proportional to the cube of t. So inversely proportional means we have some sort of y equals k over x. Y is going to equal g. And then x is the cube of t, so t cubed. So we get y equals k over t cubed. And that's that first portion. So in the next one, we have g equals 3.125 and t equals 4. We want to figure out what k is and then rewrite it. Oops, sorry, this should be g and not y. So you have 3.125 equals k over 4 cubed. You can solve this. You end up getting k equals 200. So if you rewrite it, you have g equals 200 over t cubed. And that's your answer. So to step it up a little bit, we have a longer problem. So here it says, Kepler's third law of planetary motion states, the square of the time in days it takes for a planet to revolve around the sun is proportional to the cube of its average distance from the sun in gigameters. Earth's year is 365.2 days long and has an average distance from the sun of 149.6 gigameters. Mars's average distance from the sun is 227.9 gigameters. How long does Mars's year last? So we want to first start by writing the equation. If we look at just the first sentence here, we can find some information. So we want to decide, is it proportional or inversely proportional? So we can look here and it says proportional right there. So right off the bat, you know that we're looking for some sort of y equals kx. Keep looking, it says the square of the time in days is proportional to the cube of the average distance. So I'm going to use t and d for time and days or time and distance, but it's up to you what variable you want to use. You don't have to use the same thing. So this would have that our y is the square of the time and days, so t squared, and our x is going to be the cube of the average distance, so x cubed. So your equation would be y equals, not y equals, t squared equals k d cubed. And that's the first step. Next step then is we want to look at the next sentence. So we're looking at Earth's year is 365 days. Its distance is 149.6. So pulling information from this, we have days and or time and distance. So we can then plug that in. So t was 365.2 and d was 149.6. Plug that in, you get 365.2 squared equals k times 149.6 cubed. So solve that. Square the left side, cube the right side, divide, and k will equal 0.0398. Okay, now we need to rewrite our equation. Plug that back in. So go back up to the orange and we'll get t squared equals 0.0398 d cubed. And now we're ready for the last sentence. So if we go back up here, the last one was Mars's average distance from the sun is 227. How long does a year last? So it gives us the distance and we're looking for the time. So time is what we're looking for. Distance was 227.9. So we can then just plug those in. So t squared equals 0.0398 times 227.9 cubed. And then you can solve this. It will end up giving you t squared equals 471,103,000.1922. Take the square root of both sides and you'll get 686.3696 days. And then make sure that makes sense, of course. But that would be your answer. So lots of steps, but each step itself is not that complicated. Your assignment is 2.2, so make sure you check on Schoology to make sure it's the right one. And that's it.